Okay, I'm going to explain a little bit more in depth about end behavior, and to do that, I'm going to use the practice problems from lessons 8 and 9. And so I'll have those available to you as well. So match each polynomial with its end behavior. We want to take a look at the first one. F of x is equal to 2x cubed plus 3x to the fourth plus x squared minus 1. So first off, I notice that 3x to the fourth is my leading term because that has the highest degree, and it's positive, and the degree is even. And so with even numbered degrees, the graph is going to have end behavior that is um, the same on both ends. In other words, as x increases left and right to positively and negatively, f of x, or the function, is going to go in the same direction. So for example, as x gets very large this way and this way, f of x is going to either get very large positively or negatively in both directions. So with this particular one, though, it's a fourth degree polynomial, and we've got a positive coefficient on that. So I would say that as x gets very, very large in either the positive or the negative direction, f of x gets larger and larger in the positive direction. So I would match that up with number 1. And it looks as though I would do that with the letter B as well. My leading coefficient there is x squared, and this is actually more similar to the graph that I had drawn earlier, but it's going to be a parabolic graph, and so it's going to go down and come back up, or could like that, or however it looks. But anyway, because that leading coefficient is positive, and because it has a even degree, it's going to get larger and larger as x goes very, very large negatively, and as x gets very, very large positively. And it looks as though that's going to happen with letter C as well. We have an even coefficient, so end behavior is going to be the same on both sides of the y-axis there. And there's a positive coefficient there, so it's going to be getting larger and larger positively as x goes this way, and as x goes this way, f of x is going to be going up on both ends. So end behavior is the same for even numbered degrees, and it's the opposite for odd numbered degrees. So for example, the last one here, f of x is equal to 2x plus 5. Since my leading term has an odd degree, this is going to decrease in one direction and increase as x goes in the other direction. But since it's positive, that's a linear function, so we're going to be looking at a line similar to this. So as x gets very, very large in the negative direction, f of x is going down in the negative direction. And as f of x gets very, very large in the positive direction, f of x is going up in the positive direction. So as x gets larger and larger in the positive, x gets, no, number 2 doesn't work. As x, let's see, as x gets larger and larger in the positive direction, f of x gets larger and larger in the positive. It does work, sorry. 2 does work. And as x gets larger and larger in the negative direction, f of x gets larger and larger in the negative direction. Yes, so letter D would be described best by number 2. And we don't need 3 and 4. Number 2 here, which polynomial function gets larger and larger in the negative direction as x gets larger and larger in the negative direction? So we're looking at something that as x gets larger and larger in the negative direction, this way, which of these functions gets negative. So which of the functions goes down here on this side of the y-axis? So that first one, 5 times x squared, that degree there is even, and so we know that those are going to behave the same, those end behaviors, and since it's a positive 5 there, they're both going to be going up, so we can't use letter A for this one. Letter B, we have an odd degree for our leading term, and we have a positive coefficient on that, which does mean that it'll have this shape. If it's cubic, it'll start down, make that little snake or S shape, and then go up as x gets positive. So this one would be, this one would work. As x gets larger and larger in the negative direction, f of x gets larger and larger in the negative direction. So this one would look like that then. And letter C is an even numbered degree function, and so that's going to happen, that's going to be going up as well. So letter B is the best choice there. Same thing with D there. Number 3, the graph of a polynomial function f is shown. Which statement about the polynomial is true? So it looks like we've got end behavior acting the same on both sides of the y-axis. So in other words, as x gets large this way, f of x is going up, and as x gets large this way, our f of x or y term is going up also. So the polynomial degree is even. I would agree with that because both are going in the same direction, so that makes it not odd, obviously. And the constant term of the polynomial is even. Even constant term. The constant term is the y-intercept, so it looks like it's going through the x-axis at, let's see, 3.5. I think we're going to just go with one answer for this one. Which statement is true? I would say A is true. And we really can't tell exactly where that function goes through the y-axis, so we're not sure about that constant term. Number 4, match the polynomial with its end behavior. Let's see. As x gets larger and larger, let's see, this one is a linear function and it's going down from left to right. So A, as x gets larger and larger in the positive or negative direction, f of x gets larger and larger in the positive direction. Let's see here. Okay, sorry about that little delay there. So let's see. So this first one, f of x is equal to negative 2x plus 3, that looks like it's linear to me and it has a negative slope. So it's going down from left to right. So it's going through somewhere at x equal to 3 or y equal to 3 on the y. I would say that number 1 is not right. As x gets larger and larger in either the positive or the negative direction, f of x is not getting larger in the positive directions on both ends there. It's going opposite directions. So number 2, as x gets larger and larger in the positive, f of x gets larger and larger in the positive. That's not true. Number 3, as x gets larger and larger in the positive direction, f of x gets larger and larger in the negative direction. That's true. And as x gets larger and larger in the negative direction, f of x gets larger and larger in the positive direction. So I would say A is best described by statement 3. Letter B, that looks quadratic to me because of the x squared, and so we're going to have n behavior that's the same, and since the term is positive x squared, it's going to be going up. So I think that goes with number 1. Statement number 1 works well to describe letter B. Letter C, the degree is 2 again, but this time it's a negative leading coefficient. So our leading term is negative, which means this is going to be going down in both directions instead of up. So let's see if, so as x gets larger and larger in the positive, and f of x gets positive, as x gets larger and larger in the negative, f of x gets larger and larger. Oh, I didn't see that cube term out there. This is not, this is my leading term. So this one is going to look like that. As x gets large positively, my x cubed will get large positively. And as x gets large in the negative direction, my f of x, x cubed will get very large negatively. So this would be best described by statement 2. And then D is a even-termed polynomial again, even degree, and it's negative, so that's going to be going down in both directions. So let's look at this one down here. As x gets larger and larger in either the way, then f of x gets larger and larger negatively. That would be the best description for that one. Number 5, state the degree and end behavior of this function. So the degree is 3. And since that's a negative in front of that, it's going to start high and go low, because as x gets large to the negative direction, my x cubed is going to get very large positively, because it'll be a x cubed, and then that negative out in front will flip it to a positive number. And then as x gets very large in this direction, to positively, I will get a positive when I cube it, but then that negative out in front will make it negative. So this is going to be, let's see, as x gets very large in the negative direction, f of x gets very large positively. And it's just the opposite. As x gets very large in the positive direction, x gets very large negatively. So let's move on to number 6 then. The graph of, I have to erase that. The graph of a polynomial function f is shown. Select all the statements true about the polynomial. So this looks like a cubic polynomial to me. It starts low, goes high, makes that snake or S shape around the origin there, and then heads up to positive infinity again. So the degree of the polynomial is even? No, because end behavior is going in 2 different directions. So that makes it odd. So we want to select all this time, so we know that there may be another true statement here. The leading coefficient is positive. Yep, that's behaving just as if we had y is equal to x cubed. So it's because it's low down, or it's negative down here. As x gets large negatively, f of x is getting large negatively. And as x gets large positively, f of x is getting large positively. There's no negative number out there to flip our intuition there. So this would not be true. D would not be true. The negative the leading coefficient is not negative, and the constant term of the polynomial is positive, we can tell that that's true. It goes through the y-axis somewhere above 0 there, so that's true, and we can't tell for sure if f is true then. And hopefully this helps a little bit. Like I said, I will be providing this for you to take notes on as well. So let me know if you need more explanation, and I'm always available during office hours. So thank you.